Hello everyone, I am Agnes Anto, PhD Research Scholar from the Department of Civil Engineering, Indian Institute of Technology, Bombay, India. I had completed my grade secondment spanning from the months of March to June. Under the supervision of Professor D.N. Singh, Indian Institute of Technology, Bombay, and Professor Charles Knapp, University of Strathclyde, Glasgow. My work during the secondment was on studies on the feasibility of industrial byproducts to improve MSW leachate properties. The need for this study, to begin with the genesis of the problem, the decomposition of the organic fractions of the MSW which is present in the landfills generates leachate, which is a combination of organic and inorganic contaminants which would either be in dissolved or suspended state. The leachate should be treated to bring down the contamination levels within the permissible limit prior to its disposal to land or water bodies. For the same, different types of leachate treatments are available. Recirculating back the leachate into the same landfill, which is followed in bioreactor landfills, biological methods using aerated lagoons, anaerobic reactors, or by employing activated sludge, which is rich in microbial consortium and makes the reduction of organic and inorganic contaminants in MSW leachates possible. The third method is the physiochemical methods, which include flocculation and precipitation by addition of external chemicals, adsorption, say for example on activated carbons, oxidation using ozone, hydrogen peroxide or Fenton's reagent, membrane filtration, which uses a permeable membrane to mechanically separate the contaminants from the leachate, ion exchange using zeolites or resins, basically done for heavy metal removal from MSW leachates. However, these methods have challenges associated with the functioning. Few of them are: the leachate varies its properties from time to time, large volumes of leachate to be treated, the methods like membrane filtration, ion exchange, oxidation are expensive in nature, it consumes natural materials, say for example in flocculation, precipitation, the use of alum, ferric chloride, etc. And different types of treatment methods should be used in combination to achieve the leachates with contaminants within the permissible limit. So identification of the suitable combination of treatment method is also challenging. Keeping this in mind, the scope of the work was defined to study the feasibility of industrial byproducts to improve leachate properties. Industrial byproducts are basically the waste which is generated from industries, which is to be discarded. Studying its feasibility to improve MSW leachate properties would be something beneficial. To carry out this study, the materials used were leachate samples, which were obtained from an anaerobic digester and an engineered landfill. The industrial byproducts basically involved zeolites, which were obtained by alkali activation of fly ash, bauxite residue from aluminum industry, and steel slag from steel industry. Apart from that, an additional natural zeolite mineral was also used for the study. The methodology followed was characterization of leachates and industrial byproducts and zeolites, batch studies, which was used for studying the interaction of the industrial byproduct and zeolites with MSW leachate, and characterizing the final treated leachate which is obtained after the interaction. As you can see, the properties of the leachate which is used for the study are as follows. It had a pH above 8, which indicated that it was quite matured, high level of COD contaminations, The ORP values, which were negative, indicated that the leachate is in anaerobic state or it's rich in anaerobes. The values of TDS, EC, salinity indicated that there are lots of dissolved charge carrying contaminants, basically inorganic in nature. Ammonium ions were quite abundant, and also ammoniacal nitrogen. The properties of the zeolites used and slags used in the study were: pH indicated the materials are alkaline in nature. Particle size used for zeolites were less than 75 micron, and for slags greater than less than 150 micron. The zeolites used were a natural zeolite, which is a mordanite, a fly ash zeolite obtained by alkali activation of fly ash, a steel slag, which is rich in portlandite and calcite, and a byproduct from alumina industry, which is termed as bauxite residue, which is rich in quartz mullite and calcite. The methodology adopted for batch test was: leachate and slags and zeolites were proportioned in the ratio of 1:10 in glass vials. Samples were then subsequently incubated at 40 degrees Celsius in anaerobic conditions for 2 days. Later, it was closed airtight and then mechanically stirred for 9 days. After the interaction of the samples were left undisturbed for a few hours so that the settlement of solids takes place. The supernatant was further decanted and stored at 4 degrees Celsius for further laboratory analysis. You can see the picture of glass vials which had leachate plus slags and leachate plus zeolites in the proportion 1:10. The observations from this study were: there was a reduction in ammoniacal nitrogen and ammonium ions. Not much reduction in COD was observed. There was reduction in total dissolved solid, and the maximum reduction was seen in using steel slag compared to zeolites, whereas there was an increase in TDS when bauxite residues were used. The further studies required in this context are: optimum liquid-solid proportion should be established. Interaction time also should be established so that the maximum removal of contaminants is possible, and the overall kinetics of the process is to be established. Thank you.